For the function f of x is x squared, find the gradient function or derivative using first principles. Hence state the gradient at x equals 2. So what we're going to do, we know that we have x squared, we know the shape of that, is we're going to look at a general point here, P, which has coordinates x, and the y-coordinate, since the function is x squared, would be x squared. Remember, the y-coordinate's found by squaring whatever x is. If we take q at x plus h, so what we're saying here is that this distance is h between these 2 points, then the y-coordinate is x plus h squared. The function is x squared, so we just square the x-coordinate to find the y-coordinate. And that means that this vertical distance here is x plus h squared minus x squared. So the gradient of this chord here, which we'll call delta y over delta x, difference in the y over difference in the x, is going to be x plus h squared minus x squared all over h, which is the difference in the x coordinates. So that's going to be x squared plus 2hx plus h squared, take away x squared all over h. The x squareds cancel out, so we have 2hx plus h squared over h, which is 2hx over h plus h squared over h, which is 2x plus h. Now dy dx is the limit as h tends to 0 of delta y over delta x. So that's not going to affect 2x, but the h is going to become 0. And so it's just going to be 2x. So this is the gradient function for x squared. And what that means is if we know the x-coordinate of a point, we can find the gradient at that point by just doubling it. So in the question, we're asked to state the gradient at x equals 2. So dy dx evaluated when x is 2 is going to be 2 lots of 2, which is 4.